Hello everyone. In this session I am going to explain the problems. We studied the simple harmonic oscillator theory and what are the types of oscillations and what are the spring constant and what is its physical significance and all, and mechanical simple harmonic oscillator and how to what are the periodic time period formula. Mechanical oscillator, in that case we find out what is the time period and frequency for simple harmonic oscillator. So, now we have to apply by using all these theory concepts. Now we have to solve the problems. So here one problem is that what is that? Here given a mass of 0.5 kg causes an extension of 0.03 meter in a spring and the system is set for oscillation. Now we have to find out the force constant of that spring and angular frequency and time period t. So that we know what is the time period and force constant formula and angular frequency. So first write it, what are the things given. Okay. So that is, now we have to find out the solution. So in that, what are the things given? A mass of 0.5 kg, a mass that is mass is given 0.5 kg causes an extension of 0.03 meter. So that means if we show in the terms of diagram, that is, so any spring that is attached with the mass of 0.5 kg, its mass is 0.5 kg and due to that mass extension of that spring, that is 0.3, we can take it that has extension 0.03 meter and the system is set for oscillation. So when this spring is attached with the 0.5 kg and that extension is 0.03 meter, then what is the spring constant of that spring and what is the time period formula for that and what is the angular frequency. So that we have to calculate now. So we know what is the spring constants. The spring constant means we know how much it is having the quality of extension and compression of that spring. It is the measure of the strength, extension of the spring, extension and compression of the spring, how much we can stretch that spring. So that is the spring constant. So we know the formula for the spring constant, but that is from Hooke's law. By using that we can calculate. So first let first calculate the spring constant, that is a force constant K of the spring. So what is the formula from Hooke's law? We know that F is equal to Kx. Okay. So here we are taking general F is equal to Kx, that is then K is equal to F by x. When the particle is executing with the acceleration due to gravity, so then we can write F is equal to mg. So mg by x. So this is the formula. Acceleration due to gravity value we know g is equal to 9.8 meter per second. That now and m value is given and extension value is given. So calculate the spring constant, that is K is equal to mass is 0.5 and the acceleration due to gravity value is 9.8, that we know 9.8 and the extension value is given, that is x is equal to 0.03 meter. Okay. So then calculate this value, then we will get K is equal to 166.3. Okay. So then we will get 1 63.33. Okay. So then what is the unit for spring constant? Newton per meter. So K value what we got? K is equal to 163. So next what we have to calculate? We have to calculate the angular frequency. So what is the formula to calculate the angular frequency? So that is omega is equal to, we have the formula omega is equal to 2 pi f, and we have formula omega in terms of spring constant, that is omega is equal to root of K by m. Okay. So now K value is what? 163.33 and m value is 0.5. So then what is the value we will get? By using the calculator, and we will calculate this, then we will get 18.07. Okay, what is the unit for the angular frequency? That we know, radian per second. So this is the angular frequency value. So after getting the angular frequency, then we can calculate directly the time period. What is the relation between time period and angular frequency form? So that is, we have time period formula, T is equal to 2 pi by omega. Substitute 2 into 3.142 pi value, and what is the omega value we got? 18.07. So by using the calculator, calculate it, then we will get okay. So then we will get T is equal to 0.35 seconds. So this is the time period formula. So that means the particle is executing oscillation with the spring, this spring having the spring constant value is how much? 163.33 Newton per meter, and the angular frequency, what is the angular frequency it is producing? That is 18.07 with the time of 0.35 second. So this is about this problem. A free particle is executing SHM in a straight line. The maximum velocity it attains during any oscillation is 62.8 meter per second. Find the frequency of oscillation of its amplitude is 0.5 meter. Okay. So now a particle which is executing a SHM, okay. So in a straight line, its maximum velocity, what is the maximum velocity it attains in the while it's oscillating? So a particle, if we consider any particle which is executing in a oscillations, which will executing a oscillations in a straight line, okay. So particle is executing oscillations in a straight line with a maximum velocity. That means, so at the center the velocity will be maximum. So that what is the velocity? The maximum velocity is 62.8 meter per second. Okay, the particle. Then find the frequency of oscillation of its amplitude. So we have to find out what is the frequency, at what frequency the particle is oscillating. So to find out the frequency, what is the formula we have? That is F is equal to F is equal to omega by 2 pi, right. So omega, angular frequency is not given. So first we have to calculate the angular frequency. How we can calculate the angular frequency? Because we have the maximum velocity value. From that, what is the formula? So for maximum velocity so that we have to use. So, what are the things first given? Write it. Given V max value is 62.8 meter per second, and the frequency we have to calculate. So, to calculate the frequency, first we have to calculate the angular frequency. Okay. So, here only the velocity maximum is given and the amplitude at what the particle is oscillating, the particle oscillating with the amplitude of 0.5 meter. Okay. So, then what is the formula we can use? That is V max, maximum velocity V max is equal to A omega its center when the particle is oscillating at the maximum velocity that it will be at the center. So, V max is equal to 6. Then amplitude we have, what is the amplitude? That is A is equal to 0.5 meter. Now substitute, then we will get V max is equal to 0.5. V max also omega is equal to V max by A, this will become. So, now substitute V max, what is the 62.8 and the amplitude is 0.5, then what we will get? So, calculate this value by using the calculator, then we will get omega is equal to 125.6. So, what is the unit for angular frequency? Radian per second. So, this is the angular frequency. So, next I have to calculate the frequency. To calculate the frequency, what is the F is equal to omega value? What we got? Just substitute that omega value 125.6 and next 2 into 3.14. Then frequency, what is the frequency we used to get? That is F is equal to 20 hertz. What is the unit for frequency? Hertz. So, this is the angular frequency and frequency for the particle which is executing with the velocity of maximum, that is 62.8 meter per second. This value we used to get. Similarly, next problem. So, here a spring undergoes an extension of 5 centimeter for a load of 50 gram weight. Find its frequency of oscillation if it is set for vertical oscillations with a load of 200 gram attached to its bottom. Then ignore the mass of the spring. So, here a spring that is executing a oscillation attached with the mass 50 gram and executing that extension which is undergoing a extension of 5 centimeter. That extension is 5 centimeter. Okay. So, at this point, so what is the spring constant? First, if we find, and next find its frequency of oscillation if it is set for vertical oscillations with a load of 200 gram. So, that is next. First, we have calculate from this spring constant, that is solution. So, what is the given? Extension is given, that is how much? 5 centimeter. So, if the values is in terms of centimeter, first we have to convert into meter. So, if we convert this into meter, then we get 5 into 10 to the power of minus 2 meter. X is equal to, and what is the weight? M is equal to 50 gram, and if it is in gram, then we have to convert this into the kg. So, how to convert? Divide by 1000, then we will get 50. That 50 gram will become 50 into 10 raised to minus 3 kg. Okay. So, now what is the formula we have? F is equal to Kx and K is equal to F by X. And what is the force for formula? That is M into G divided by X. So, what is the M value? 50 into 10 raised to minus 3, and G, acceleration due to gravity, that is 9.8. And what is the extension? 5 into 10 raised to minus 2. So, if we calculate this, then what we will get? So, here 5, this will get cancelled, same value, then we will get 9.8. So, what is the unit for spring constant? Newton per meter. K is equal to 9.8 Newton per meter. So, this is about this spring when it is attached with the mass of 50 gram. Okay. So, the next problem is a mass of 5 kg is suspended from the free end of a spring when set for vertical oscillation. The system executes 100 oscillations in 40 seconds. The system executes 100 oscillations in 40 seconds. Calculate the force constant of the spring. So, that is a spring which is attached, which is suspended with the mass of 5 kg. With the mass of 5 kg, and which is executing a oscillations, 100 oscillations for 40 seconds. Okay, 100 oscillation for 40 seconds. Calculate the force constant of the spring. We have to calculate what is the force constant of the spring at this condition when the particle is executing 100 oscillation for 40 seconds. So, what is the spring constant? So, to calculate the spring constant, what is the formula we have? So, that is first a solution. So, what are the given things? Write it. Mass is equal to 5 kg, and here oscillations is given 100 oscillations per 40 seconds. So, that means frequency. So, frequency is equal to what? Number of oscillations per second. What are, how many for? So, what is that number of oscillations? That is 100 oscillations. So, what is the second time given? 40 seconds. Okay. So, then calculate the frequency. Then what we will get? F is equal to 2.5 seconds. So, if we simplify this, then we will get frequency F is equal to 2.5 seconds. Then what is the relation between frequency and spring constant formula? So, that is calculate the force constant. What is the force constant? How much we can expand or compress this spring. Okay. So, what is the physical, what is the quality of that spring? So, next calculate the frequency. So, next calculate the spring constant. So, what is the frequency and spring constant formula? That is F is equal to 1 by 2 pi root of K by M. Okay. So, now substitute 2 into 3.142 into K value we do not know, we have to calculate the force constant of the spring value. What is the M value? 5 kg. So, frequency, make the rearrangement. So, apply the square on both sides, then what we will get? F into, that is that will become K is equal to F into 2 into frequency value we know, just substitute the frequency value 2.5 into 2 into 3.142 whole square, okay, in whole square into 5. Then if we simplify this, then what? 1232.45 Newton per meter. What is the unit for this spring constant? So when the spring attached with the mass of 5 kg, so what is the spring constant of that spring is, that is K is equal to 1232.45. So that is the spring constant value for this spring.